Hello everyone, today we are going to talk about the innermost planet of our solar system, that is planet Mercury. So before we begin our video, let's put across some facts about Mercury. So Mercury is the innermost planet of our solar system. It is also the smallest planet in our solar system. It is closest to the sun and the distance is approximately on an average 0.3 astronomical units. It rotates in 59 days, whereas it revolves around the sun in 88 days. Its axial tilt is very less, that is the axis around which it rotates is almost perpendicular to the orbital plane. So which is why there are almost no seasons on Mercury. So now let us see what the mass and radius and other basic properties of Mercury are with respect to Earth. So mass of Mercury is nearly 0.05 times that of Earth. The radius is 1/3 that of Earth. That means on the diameter of Earth you can actually place 3 Mercury planets side by side. The density of Mercury is almost equal to that of Earth, whereas the escape velocity is nearly less than half that of Earth, and it has no natural satellites. So let us see what the structure of Mercury is like. Almost like all other planets, Mercury has a core, except that the core is very large, that is it is about 85% of the radius of Mercury. Just outside the core there is an outer shell and it is almost similar to that of Earth again. It is about 400 kilometers. The outermost layer is obviously the surface. Now surface of Mercury is not very plain, it is made up of cracks, it has many impact craters. The impact craters are majorly because of the asteroids or meteorites that fall on the surface of Mercury, and the cracks are because when Mercury was formed after a few million years it started cooling, and because of which its core started shrinking, and hence there were many cracks, there were many ridges that formed on the surface of Mercury. So in this image you can see that this particular feature here, that is a crack that is formed on the surface. So similar to the tectonic plates on Earth, Mercury also has tectonic plates, but the only difference is that there are no plates, there is a single plate. So the entire Mercury has a single tectonic plate. This is an image of an crater which is about 95 kilometers in diameter, and its name is Hokusai crater, and this was clicked by MESSENGER probe. This is another crater, so this is actually the largest crater on the surface of Mercury, about 118 kilometers in diameter. So the temperatures on Mercury are quite extreme, but at the same time it is not the hottest planet. In spite of being the closest to the sun, Mercury is not the hottest planet. The daytime temperature is about 430 degrees Celsius, whereas at night it gets as cold as minus 180 degrees Celsius. Now in spite of being closest to the sun, it is not the hottest. Venus is actually the hottest planet, and the reasons about that we have discussed in another video. In spite of being closest and extreme temperatures, there is also an interesting feature which I told you, that the axial tilt is almost 0, because of which it is vertical. So the sunlight that reaches the poles is very less, and there is a crater like thing at the pole. So this is a picture of the north pole of Mercury. So inside this crater the temperature is as low as minus 170 degrees Celsius. It never gets hotter than that. So it is very cold, and it is expected that there is some water ice here. So in spite of being the closest to the sun, Mercury also has ice. So these particular structures are called as cold traps, because these are very cold and the temperature never gets higher than minus 170 degrees Celsius. So after the outermost layer, that is the surface, we have atmosphere, but Mercury does not have any atmosphere. So we have 3 reasons here. The first one is that its gravity is very low, since its size is very small, the mass is very small, the gravity is very low, and hence it could not hold the gases. The other thing is, being closest to the sun, the temperature is comparatively high, although not the highest in the solar system, the temperature is high, because of which the kinetic energy of the gases was very high, and it was higher than the gravitational binding energy, and so it is said that might have had atmosphere in the past, but now there is no atmosphere. The third reason is that because it is closest to the sun again, it experiences very heavy solar winds, and so it is also expected that some little atmosphere that was there, it might have gotten blown away. Even though it does not have an atmosphere, the layer just above the surface, it is expected that it has a thin exosphere, which is made up of atoms that are blasted off when there are some impacts due to the meteoroids. And this exosphere is made up of these atoms: oxygen, sodium, hydrogen, helium and potassium. An interesting feature of Mercury is that it has a tail. It is not a comet, it is a planet, but it does have a tail. So, this tail is made up of again sodium atoms which get blasted off the surface when meteoroids impact. The color is almost yellow orange and the tail can get as long as 24 million kilometers. So, because Mercury was very small, it was expected that it would not have a magnetic field or very low magnetic field. So, a spacecraft named Mariner 10, which was actually a flyby, it actually detected some magnetic field which was very low, and that was almost 1% of that of Earth. So, there are very few missions that have actually gone and studied Mercury. The first one was Mariner 10 that we saw. There was another flyby, but there was one important spacecraft that was actually an orbiter. So, that launched in 2004, which reached Mercury 6 years later. And there were many important things that we discovered about Mercury. We found out that there were high concentration of magnesium and calcium. Also that the magnetic field of Mercury is not exactly aligned with that of the rotational axis. It has some offset. It was also discovered that there were some water molecules in the exosphere, that is the outermost layer of Mercury. And there was also some evidence of some volcanic activities in the past. One interesting thing about Mercury is that it is tidally locked to the Sun, but it is not like our Moon. So, our Moon is tidally locked to the Earth, but it is synchronously tidally locked. That means its revolution period is equal to the rotation period, and which is why we see only one face of Moon. But it turns out that there is more than one way of tidally locking a body to another body. So, Mercury is tidally locked to the Sun in 3:2 resonance. So, its spin orbit resonance is 3:2, that is, in 2 revolutions it completes 3 rotations. So, in the first slide we saw that its orbital period or the revolution period was 88 days, whereas rotation period was 56 days. So, in 2 years it completes 3 rotations. So, this was not discovered in the past, and the reason being that whenever Mercury was best suited to observe in the sky, it was always in the same point in its 3:2 resonance, and hence we saw only the same side of Mercury always. And this was because the rotation period of Mercury is exactly half to that of the synodic period of Mercury with respect to Earth. So, earlier we thought that it is synchronously tidally locked to the Sun, but turns out that is not the case. So, this was found out in 1965 by radar observations that it actually has 3:2 spin orbit resonance. Another interesting fact about the orbit of Mercury is that it is strongly elliptic as compared to the orbits of other planets in the solar system. Also, this orbit precesses as a whole. So, if you see in this diagram, you see many orbits here, and the blue points here are actually the point at which Mercury is closest to the Sun in that particular orbit. So, if you see that with time, this particular point, it changes its position, that means this orbit is precessing as a whole. So, the reason for this was thought to be that apart from the gravitational force that Mercury experiences from the Sun, all the other planets, that is all the outer planets, they also exert some force on Mercury, and because of which the orbit precesses. Now, the rate of this precession was calculated to be of some value, but this value did not match with that of the one found out from the observations. So, this was a problem, and scientists then thought that this might be because there might be another innermost planet in the solar system which might influence the orbit of Mercury, and started searching for such an innermost planet, but they could not find it out. So, this was a persistent problem, and the solution to this problem was given by Albert Einstein when he proposed the general theory of relativity, and the value for precession of Mercury's orbit that was calculated based on this theory it matched with that of the observations. So, that is it for this video. Thank you.